basic derivatives, product rule, Lagrange's notation. So the way he does it is you have a function, in this case it's h, and the variable is x, and it equals two functions multiplied together. So that's over here is an example where you would have a function and inside is x multiplied by x, which would be two functions. You could do this faster other ways, but when you have more complicated ways of multiplying two functions, product rule is the way of doing it. And when you derive it, you end up with the derivative of f multiplied by g, then you add f multiplied by the derivative of g. So if we look at some examples, help that sink in. Example 1. Let's say h is x multiplied by 2x plus 5. Now, we can think of that on the other page, hx also equaled fx multiplied by gx, which is a function times a function. In this case we have x multiplied by whatever's in the bracket. In the bracket there is another x, so that's a function times a function, just like here. So if we split the page and we write fx, we can call it x. We can label x as fx. And we can label everything in the brackets as gx. So that'd be 2x plus 5. Now the derivative is f dash x multiplied by gx plus f x multiplied by g dash of x, which is the derivative of f multiplied by g plus f multiplied by the derivative of g. So if we were to do those over here, separate our workings, derivative of x equals 1, the derivative of 2x plus 5 equals 2. So if we fill this in, f dash of x is 1. It's 1 multiplied by gx, which is 2x plus 5. Then we add fx, which is just x, multiplied by gx, which is the derivative of gx, which is just 2. So to simplify this further, multiply the 1 in, and multiply the 2 by the x. We can simplify it again. Right, 4x plus 5. So that is the first derivative of this up here. Now, another example. We've got, let's say, (3x squared) multiplied by 6x to the power of 5 plus 7x. So if we split the page again and we write out the formula, we can label accordingly. So fx can be 3x to the power of 2, and gx can be 6x to the power of 5 plus 7x. Now, the derivative is f dash of x multiplied by gx plus f of x multiplied by g dash of x. So, to find f dash of x, or the derivative of f, we just 6x, and finding the derivative of g, or g dash of x, is 30 x to the power of 4 plus 7. So to sub that in, bring it down here where there's more room. f dash of x is just 6x multiplied by gx, which is 6x to the power of 5 plus 7x, plus fx, which is just 3x squared, multiplied by g dash of x, which is just 30x to the power of 4 plus 7. And that there is the first derivative of this up here. Now, for another example, just to finish this off. Okay, so say h equals 3x to the power of 3 plus 4, multiply that by 5x to the power of 6 plus x to the power of 4. Now, we can put a little section in the page where, because hx, we can label accordingly. Again, fx can be this up here, 3x to the power of 3 plus 4, and gx can be this here. So the derivative is f dash of x multiplied by gx plus fx multiplied by g dash of x. So we need to find the derivative of both of these, which would be 9x, or derivative of f would be 9x to the power of 2, and the derivative of g would be 30x to the power of 5 plus 4x to the power of 3, because you bring the 6 down and you bring the 4 down, and that's what you would end up with. To sub those in, f dash of x would be 9x squared multiplied by gx, 5x to the power of 6 plus x to the power of 4, plus fx, 3x to the power of 3 plus 4, multiplied by g dash x, or the derivative of g, which is 30x to the power of 5 plus 4x to the power of 3. And that there is your derivative, first derivative of this function at the top. Thank you.